Section 4.4 is on page 330, talks about the indefinite integrals and net change theorem. So we have two types of integrals. We have indefinite integrals, and that's you saying I'm going to integrate some function f of x with respect to x, and you'll say that's f of x plus c, where anytime I take a derivative of this capital F of x, I'll get the little f of x, which is this. We also have a definite integral. Definite integrals, and those are the two types of integrals that we deal with almost all throughout. Indefinite integrals. That's when you have an integral. Did I say indefinite? I meant definite, from a to b of f of x dx. That would be an actual number, a value if a and b are given, where still the same deal. If you take a derivative of this capital F, you will get that little f. So that's pretty much the two rules we're going to be playing with all throughout this course, majority of the next courses. On page 336, we want to play with that a bit, practice this. First they start, this is really a problem from 5B, our next semester calculus. They say verify by differentiation. So they're saying verify this part. That is, if I take a derivative of my answer, I should get the integrand. That's what they're saying. Well, if this is capital F of x, then the derivative of that should be the cosine squared of x. And if I take a derivative of this, what would I get? I'll get 1/2 plus 1/2 the cosine of 2x times 2, 1/4, right? And the derivative of c is 0. I'm just writing that for the notes. That's 1/2, and this 2 cancel with that. That's 1/2 the cosine of 2x. And wouldn't that be 1/2? Cosine happen to have 3 identities. To get this cosine squared, that would be twice the cosine squared of x minus 1. And that would be 1/2. And if I distribute that in, isn't that cosine squared of x? I'm so stuck on theta. Minus 1/2. And those two cancel out. And I'm left with the cosine squared of x. Like I said, in this class, you can get away with not knowing a whole bunch of trig because it doesn't come up as much. But for the next semester and the third semester calculus, you're asking for it. How about this problem? Find the general indefinite integral. Alright, what is that? This is the integral of x to the 5/4 dx. Add 1 to the power, divide by that. That's 9/4, 4/9 plus c. There it is. This problem, you need to manipulate the problem a bit. 2 plus 1/2 is 5/2. 1 plus 1/2 is 3/2. T to the 1/2. Add 1 to the power. Divide by that. 3 times. Add 1 to the power. Divide by that. Add 1 to the power. Divide by that. And that would be 2. You could write, if you want, the square root of t to the 7th over 7. You could leave it as is. I really don't mind. You could leave it as a fractional power. If it's an indefinite, it's not going to matter. If it's a definite, you're going to have to evaluate those, so you know, something to consider. Here, if I'm looking at this, I'm trying to figure out how that works. Well, this is the integral of, and let's see, isn't that secant squared of t plus secant of t tan of t? What do you take a derivative of to get secant squared? isn't derivative of tangent secant squared. What do you take a derivative of to get secant tangent? So the work is really nice. It runs smoothly, very quick, not much to do. You should really get that out of the way. And we're going to try to do, enough problems. This is a definite integral. Be careful with that. So this is add 1 to the power, divide by that becomes x to the 4th. Add 1 to the power, divide by that becomes x cubed. Add 1 to the power, divide by that becomes x squared. Evaluate it from 1 to 2. Throw the 2 in. That is 16 minus 8 plus 4. Minus, throw the 1 in. That is 20 minus 8 at 12 minus 1, that's 11. Another definite integral. This would be the integral from 1 to 2, x to the negative 2 minus 4x to the negative 3 dx. Add 1 to the power, divide by that. Add 1 to the power, divide by that. That is negative 1 over x plus 2 over x squared evaluated from 1 to 2. Throw the 2 in. That's negative 1/2 plus 2 over 4. Throw the 1 in. Negative 1 over 1 plus 2 over 1. Now on a test, this is fine for me. For the homework, you need to clean it up and match it with the back of the book. That will be minus 1/2 plus 1/2. Distribute that in. Plus 1 minus 2, that will be a negative 1. Again, I think it's really straightforward, not that complex at all. So if I get to this problem, this is the integral from 1 to 8 of twice w to the negative 1/3 minus w to the 1/3 dw. So what we're going to do, we're going to add 1 to the power. Negative 1/3 plus 1 is 2/3. Divide by that. Minus. Add 1 to the power. 1/3 plus 1 is 4/3. Divide by that. That's actually 3 times w to the 2/3 minus 3/4 w to the 4/3. That would be evaluated from 1 to 8. So if I throw the 8 in, that's 3 times. The 8th root of, the cube root of 8 is 2 squared, that's a 4. Minus 3/4. The cube root of 8 is 2 to the 4th, that's 16. Right? Minus, throw the 1 in, that's 3 minus 3/4. So I'm looking at, need to get rid of that, there we go. I'm looking at a 12, that cancels out 4 times, minus a 12, minus 3 plus 3/4, and I'm looking at, again, on a test, I really don't mind you leaving the answer like that. This is a 4 times negative 12 plus 3, negative 9/4. That would be my final answer. And on the next problem, the same idea. I'm trying to figure out how to do this. I could split it up. I could factor. So trig is a bit tricky. Identities are a must. And you could save yourself a lot of pain if you really know those identities. And does anybody know what is 1 plus tangent squared? So this is actually nothing more than, what do you take a derivative of to get sine? Negative the cosine. And that's going to be negative the cosine of pi over 3 minus negative the cosine of 0. That is negative. Cosine of pi over 3 would be 1/2. Plus cosine of 0 is 1. That would be 1/2. Okay, I'm going to stop here. There's enough time to finish what I want, but I don't want to start the net and distance versus displacement. I want to talk about that next time. So we're going to stop here.